Hello, welcome to Introduction to Programming with Python in the second half of 2022. My name is John Ostlund and I will be your professor for this course. I'd like to start out by taking a look at the syllabus, in which we'll describe what the course is going to cover, as well as what you are going to have to do during the course in terms of submitting homework, taking quizzes, and the final exam, and how this will be used to compute your final grade. So I have multiple monitors on my machine here. It's going to appear that I am turning away from you to take a look at my screen that has the syllabus on it. Let's get to it. Okay. So, as I said, my name is John Ostlund. I have two different email addresses that you can use to contact me. My Andrew email address, which is jostlund@andrew.cmu.edu, or you can use my personal email address, jkostlund@gmail.com. All of my email gets routed to my Gmail account, actually, so it doesn't matter which of those two email addresses you use to communicate with me. Now, when I'm teaching, I tend to be working more or less all the time, so I will be available to you at least between 10 in the morning and 9 in the evening, U.S. Eastern Time, daylight time currently, or standard time at the end of the year. And I'm available 7 days a week. You can reach me by email. I'm also available on Zoom. If you have a particular question that you or your homework team would like to ask me, by all means send me an email and we can set up a Zoom session individually or for your homework team, or just for any random collection of people. So unless I'm traveling, which I'm not doing right now, I'll be available to you more or less all the time. Do not feel bad about contacting me on Saturday or Sunday. I will be available, as I said. We will have office hours during the course. You should check the syllabus for your particular section for your section's office hours. They may change. They are likely to change as the summer and fall of 2022 progress for different sections. For this particular section, which is in Mini 6, the second half of the summer of 2022, I will have office hours by Zoom every Sunday from 7 p.m. EDT, U.S. Eastern Daylight Time, until 8 p.m. on Sunday. All right, so an hour every Sunday evening. I'll also have office hours on Monday for an hour from 10 a.m. to 11 a.m. Eastern Daylight Time. And for this particular course in Mini 6, the final exam will be an online exam, and it will occur on Friday, August 5th. Now, for your particular section in Mini 1 or Mini 2 in the fall, you will want to check the office hours and the posted final exam date on your particular syllabus. We will have 2 TAs available for the section, and mainly what the TAs do is to help me with grading homework assignments. You can also feel free to email them if you have questions about the course material or about the homework. I leave it to them to decide whether they would like to hold office hours by Zoom, but I don't require them to do that. So that's up to each TA to decide whether to do that or not. Okay? Now, basically, the purpose of this course is to get you acquainted with doing computer programming using the Python version 3 programming language. Historically, there was a Python 2 with various different releases, but support of Python 2 has been officially dropped a year or so ago, or perhaps longer ago. So we're going to be using Python 3, and I'm not going to say anything at all about Python 2. In particular, this fall, we'll be working with, let me drop down a minute here, we'll be working with the version of Python called Python 3.9. Although most of what I'm going to be saying here will apply to any version of Python as far back as about Python 3.7 a few years ago. Okay, this course is intended for people who have little or no programming experience. We're going to start from doing very simple things and build to doing more complex things. We're going to introduce the idea of top-down procedural programming, where you start with a problem of some kind, where you need to get some information from somewhere and process that information and produce some result. Well, the processing can be a non-trivial problem, and so typically you break the processing down into a sequence of steps. You often write what's called a function to handle each one of those steps, and then you simply call those appropriate functions in sequence. Now, each of the subproblems may itself be rather complicated, so often within a function that you write to handle a subproblem, you'll need to break that down into further sub-subproblems and write a function to handle each one of those sub-sub-problems. That's why this process of breaking things down is called top-down. Okay? We'll have homework on a weekly basis. We'll also have quizzes to take, as well as an online final exam. And the final exam is going to be a combination of true-false, multiple choice, matching, and similar kinds of questions. You will not, on the final exam for this course, be required to actually write any code. You will, of course, have to write quite a bit of code in order to complete the homework assignments. Okay, we will do some object-oriented programming as a user of objects in this course. I'm not, in this course, going to get into the business of defining so-called classes of your own objects. All right. Now, in terms of software that we need for the course, we're going to be using Anaconda version 2022.05. That's a package that was released in May of 2022, and it includes something called Python 3.9. That's the version of the Python language that this Anaconda package includes. Now, if you are toward the end of 2022, it's possible that we will have updated to a more recent Anaconda and a more recent Python, so please check the software expectations in the syllabus for your section. You can obtain Anaconda from anaconda.com, and in fact there's an installation video that you can watch that will walk you through this entire process. There is a lot of documentation and tutorials for Python available online. The official documentation for our version of Python for this course is at docs.python.org/3.9. And there's also a tutorial introduction to Python at docs.python.org/3.9/tutorial. The tutorial is very good. You may or may not find it helpful to you. It's a little bit choppy. Some of it's easy, some of it's less easy. Nevertheless, it's probably worth taking a look at. If you would like to buy yourself a textbook, then probably the best one to get your hands on is this book called Starting Out with Python, 5th edition, by a fellow named Tony Gaddis. And unfortunately, this thing is quite expensive. It's something like $120 in that range. With recent inflation, it's probably more expensive than that. If you are willing to shell out that kind of money, it's a very good reference to have, but I never like to force my students to spend money, so whether you do that or not is up to you. There is also an introductory level book available online called Automate the Boring Stuff with Python. You can buy that physical book if you wish from Amazon or wherever. But if you check online, you'll discover that the whole thing is available for free on the web. And it's possible that what's found on the web will be more up to date than the physical copy that you can buy. For somewhat more advanced users, a really excellent book called Python for Data Analysis, 2nd edition, by a fellow named Wes McKinney. I recommend, but this book will be possibly beyond your reach until we get near the end of this introductory course. And this thing, fortunately, is available for free online through the Carnegie Mellon University Library. So if you go to the Carnegie Mellon University Library's website and do a search, you can search for Python for Data Analysis. There are 2 versions that the library supplies, both the 1st edition and the 2nd edition. You want to be very careful to choose the 2nd edition because the 1st edition uses the obsolete Python 2, and you can access the book through the library. All right. Other than that, I do want to say, Google is your buddy. And if you do have questions about anything to do with Python, never hesitate to Google for things. Do be aware that some of the recommendations that you find on Google may not be very well written, may be obsolete. So look for recent resources from 2021 or 2022, and look for resources from, for example, from college courses or what have you. Those are likely to be the best. In terms of your grade is going to be composed of 3 things. First of all, there will be homework on a weekly basis, and your grades on all of the homework will count for 20% of your overall course grade. There will also be quizzes on a weekly basis. Now, I think that contradicts something that is written up here. Yeah, I forgot to update this. It says bi-weekly checkpoint quizzes. Okay, that isn't true anymore. The quizzes are on a weekly basis, and the quizzes are not intended to be frightening. They're not necessarily easy, but the quizzes are intended to just confirm that you have learned the material covered in the week's lecture materials. The quizzes will be true, false, multiple choice, matching kinds of things. And in order to get an A on a quiz, you have to score 87.5% or better of the available points. Now, you will also have up to 4 chances to take each quiz, all right? The questions are generated at random from a question base, so it's unlikely that if you take the quiz twice, let's say, it's unlikely that the second version is going to be the same as the first version. But you have up to 4 chances to get an A, that is, to get an 87.5% score or better. I do impose one limitation on this, which is that you're only allowed to take each quiz 1 time per day. I have in the past had, well, you may not define it as a problem, but it seemed like a problem to me that people would say, okay, I've got 4 shots at this. I'm just going to take the quiz 4 times in a row and hope that I get an 87.5% on one of those tries. If you fail to get an A on a quiz, I would really prefer that you review the material and fill in the gaps in what you don't know, and then try to do better the next day. I try to discourage rolling the dice 4 times in a row and hoping for the best. All right. There will be a final exam at the conclusion. The quizzes are worth 35% of the grade. The final exam is worth 45% of the grade. And in this course that I'm teaching right now, the exam will be available online on August 5th. In your course, if you're taking the course in Mini 1 or Mini 2 in the fall, you will want to check to find out what the specific day for your final exam is going to be. Now, the exam will be open for a 24-hour period at the end of the course, and you will have one chance, unlike the quizzes, you will only have one chance to take the final exam and do the best you can. The final exam is 1 hour long, and your hour starts from the moment that you start the exam. Okay? Now, in terms of computing a final grade, as I said, the final grade is going to depend 20% on your homework, 35% on your quizzes, 45% on your final exam. And if you work diligently and manage to get an A on each quiz, which you really should, and if you manage to get an A on each homework, which again you really should, then it is possible that you can get an A+ in the course by getting an A+ on the final exam. All right, I don't give A+ for homeworks, and I don't give A+ for quizzes, because on homeworks, you work with at least one partner, and you can actually work with as many people as you wish. Likewise, on quizzes, I give you 4 attempts. So it's only on the final exam that it will be possible to get an A+ if you are among the very top performers on that final exam. Okay? And so if you get an A on all your homework, an A on all your quizzes, and you get an A+ on your final exam, you can get an A+ for the course. Basically, I compute the final exam, I compute your course grade, your final course grade, using these GPA points corresponding to the letter grades. Now, Carnegie Mellon, what most people refer to as GPA, Carnegie Mellon, including the Heinz School, labels these as QPA points, but the idea is the same. So I convert the letter grades into these numerical scores as defined by Heinz College. I then compute a weighted average of that numerical score to get a final weighted average score. That weighted average score is then used, again, in this table to determine what your course grade is. Now, I round to the closest letter grade rather than truncating. So in this case, we're assuming that you have received an A on all your homework, so that's 20% of your grade is an A. You've gotten A's on all your quizzes, so 35% of your grade is an A. And we're assuming here for illustration that you got an A minus on your final exam. Okay, so your A minus is 45% of your final grade. Now that computation produces 3.8515. Because I round, if this were your computed average, it turns out that 3.8515 is closer to 4 than it is to 3.67. So you will end up getting a course letter grade of A in this particular example. Okay? So you should be able to, you can compute this weighted average score yourself, and then you can determine which of these letter grades your weighted average score is closest to, and that will be your letter grade for the course. In order to get an A+ in the course, your QPA has to be strictly greater than 4, all right? So if you do this weighted average and you get a 4.0001, well, that's strictly greater than 4, so you get an A+. If you get a 4.0000, that's equal to 4, and so you get an A. I realized that I neglected to mention some details about the homework, so let me back up for a moment here. All right, in my courses, including this one, I don't look at homework as something that you have to do yourself in isolation, seek it from everybody else. Instead, I view homework as an opportunity for learning the language, for practicing writing code, and also for working with other people and communicating with other people to discuss your ideas about how to write code and how to solve problems. So for each assignment, I am going to assign each of you to a team of usually 2, but sometimes 3 people. If I have an odd number of students, of course, I'm going to have one group of 3. And the idea here is you should do as much of each homework yourself as you can, but then once you have done as much as you comfortably can, discuss with your teammates, or for that matter with anyone else that you wish, other students who are not your teammates, obviously the TAs or me, and get your homework finished by communicating with others on things that you're stuck on. Now, in particular, before you submit your homework, you're going to want to compare what you did with what your team members did, and decide which homework you want to submit on behalf of the team. Okay? It might be your homework, it might be your partner's homework. You might decide to create a new solution that is a merging of the 2 different solutions. And then finally, one team member should submit a zip file of the homework solution to Canvas. And that solution will then be scored, and everybody in the team will get the same grade. Now, I don't want you to be panicking about grades for homework. I do not rank people on homework on a point-by-point basis. I really feel that it is kind of ludicrous to claim that a person who scored a 98 on a homework is somehow better than a person who scored 97 on that same homework. I don't grade for perfection. I grade for understanding and knowledge and experience, or at least I try to. So in order to get an A on a homework, out of 100 points, you need to get a score of 90 or better. And if you work on the homework seriously, and if you discuss with other people, most particularly your teammate, but also other people, it is extraordinarily rare for a team to get less than 90 points on a homework assignment. So, take the homework seriously, learn the material, practice writing code, talk with your teammate, talk with other people, and if you only get a 92, well, you got an A, and that's as good as the A that some other team that got 98 got. So, don't panic. Don't try to fight for individual points. If you did something that one of the TAs decided wasn't quite perfect on a homework assignment, just look at what their what the TA's suggestions were. Brush up on whatever you had trouble with, and get on with your life. Okay, so homework is graded. There are also some labs that I will publish each week, and these are just for your own practice and experimentation. The labs will not be graded, and you can talk about them with other people, but you don't need to. You can just try the labs out and see how you do, and if you have questions, ask your homework teammate, ask other friends, ask the TAs, ask me, and we'll be happy to answer questions. All right, so the grades come from homework, quizzes, and the final exams, and the labs are just available for your own experimentation and practice. All right, well, I'm not going to read the learning objectives to you. I'm assuming that you can figure that out. I'm assuming you know how to read. Now, here is the official Heinz College grading scale. An A plus is from 97% to 100%. An A is from 93 to 96.99%. This is the let's say the baseline scale that I use for the quizzes and the final exams. However, well, I guess maybe I should just say the final exam, because I've already told you that to get an A on a quiz, you have to get 87.5%. So if you get 87.5% or better on a quiz, you get an A. If you fail to get 87.5% on any attempt at a quiz, then you will get a grade that's worse than an A, according to approximately the scale. Now, on the final exam, as I said, this is kind of the default scale. If everybody scores 97 points or better out of 100 on the final exam, everybody in the class will get an A plus. On the other hand, if the final exam turns out to be much more difficult than I expect, it's conceivable that we might have a final exam where the best score in the entire class is an 85. All right. Now, that doesn't mean that everybody is going to get a B or worse. In a situation like that, where the top score is like 85 points, the top score defines what an A plus is. And so the top score and scores that are a few points, within a few points of the top score, those will be A pluses. And then I will create a curve below there for other scores. So this Heinz College grading scale, we'll take as a default, but it's not necessarily what I'm going to apply mechanically to your final exam. All right, now here we have the course outline. Once again, I'm assuming you can read this yourselves. We've got 6 weeks. Here's the schedule showing when the various homework assignments are due. I will announce for each quiz when the quiz is due, and then, of course, the final exam is going to be due, or is going to be available and due on Friday, August 5th. All right. Now, homework assignments for this course are always going to be due on Monday, just before midnight each week. Generally, for all of my Introduction to Programming with Python courses, I have just before midnight Monday as my due date for homework. So that you should not expect to change for courses in Mini 1 or Mini 2. If it does change for those courses, I will certainly announce it. Okay, and then I believe the remainder of this you can read yourselves. Okay, so there we are. So if you do have any questions about the syllabus, about grading, about anything else, please feel free to send me an email, and I'll be happy to answer. Welcome aboard, and I hope you enjoy the course and find it beneficial. Take care.